Yes, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to our discussion for today. Basically, we're going to look at one of the evaluation questions for the concept of friction, which is a contact force that we have discussed in our previous video. Now, in this particular case, we're going to use the information provided for us to evaluate various aspects of this specific concept of friction. And these are going to entail the concept of the coefficients of kinetic friction, and of course and the coefficients of this specific static concept of static friction. Now, to have a recall of the last discussion that we had, we talked about the concept of friction basically as a force that acts to resist the concept of motion. And of course, this was concerning the discussion of two objects which we had given in terms of this rough sketch for the object of A and B, whereby one object is moving on the surface of another, and we see that they are going to experience friction, which is a force that is going to act to reduce this aspect of motion. So we categorized this aspect of friction into two specific parts, whereby we said that we're going to have a friction which is going to be described as static friction, given as a notation of this specific kind. And this is going to be a friction which can be, of course, defined by this specific object when this object is going to be staying at rest whenever a particular amount of a force is going to be applied. And there's a second sense in which we defined another type of friction as a kinetic friction, which is the friction that will be experienced whenever this object is going to be sliding on the surface of the other. So in this particular case, our evaluation today is going to require us to find the relationship between the various forces which are going to act in this specific part for a particular object of a particular weight. And just given a block diagram of this specific, or just an illustrative diagram of this specific nature, which entailed a variety of forces which are going to be experienced. Particularly, I can just give it as such. So we said that if we have an object that is resting on a surface given as such, we're going to see that according to Newton's third law of motion, there are two forces which are going to be acting on this object. One of it is its weight, and there's a force which is going to be a normal force acting opposite this one. And the two forces are going to be opposite but equal in magnitude. Now, in a sense, we said that if this object is resting on a flat surface, then therefore, if a force is going to be applied to move this specific object, this force has to overcome the concept of a friction, which is going to resist this kind of a motion in order to ensure that the object is going to slide on the surface. Now, this specific sense, then therefore, we're required to find an evaluation of a particular amount of a force. And of course, we are going to check out whether this specific relationship we had just given for the concept of this static friction equivalent to this product of a mu. So mu, we said it's a coefficient of a static friction given in that specific notation. And of course, this was the product of this mu s and n, whereby n is the normal force applied in this specific case, which is equivalent to weight. And for the second case, we said that we can evaluate kinetic friction using this specific relationship of mu k, and then this given as n. And this is the relationship between the normal force, which is equivalent to the weight, and opposite together with these two coefficients of friction for the static and kinetic given as such. So in this case, I'm going to read it through this specific question, and we're going to do an evaluation and find out what we are basically required to just evaluate for A, B, and C. So in this case, we are given a block which is 50 newtons, and this of course is going to be 50 newtons equivalent to the weight of this specific block. And of course, we're going to see that if force of T, which is going to be applied, is 20 newtons, the block is going to remain at rest. So which means the frictional force has not been overcome, and therefore we're going to consider that specific kind of friction offering a force referred to as this is specific static friction force. So in a sense, if we are required to find the static friction force, we're going to do an evaluation of that one. And as we said, of course, in this case, there are three scenarios which we're going to consider for this. If there is a force which has been applied and the object is going to remain static, that one has an implication that This is specific static friction force, of course, is greater than the force which has been applied. And we can have a second scenario whereby we're going to see that this specific static friction force is equivalent to the force which has been applied. Still, the object will remain at, of course, static as given as that. And of course, we can consider the case whereby if this specific object which has been applied, or the frictional force which has been applied, of course, is greater than 0, whereby we see that if 20 newtons has been applied at T, then therefore that implies that the frictional force which has not been moved by 20 newton, then therefore is going to be greater than 0. And the scenario number 2 is that it's either it's equivalent or they are at the state of equilibrium. Therefore, we are not going to expect specific force is going to be greater than this one. So in this case, having been given the type of this specific evaluation, then therefore we are going to have this second scenario whereby we are going to have basically this force is going to be greater than 0, and of course this force is going to be greater than this. So we're going to consider this specific case whereby we're going to have this T equivalent to the force applied, which is equivalent to the 20 newtons which we have been given. So in this case, we're going to consider our option for B, and of course, we're going to have this one. If T is increased to 40 newtons, the block starts to slide. So in this case, we're going to look at this particular kind of a wording. If T is increased to 40 newtons, the block starts to slide. So in our previous discussion, we said that basically for this specific block to move, we're going to have the maximum static force being applied in order to ensure that this block moves. And this, of course, is equivalent to this particular relationship whereby we said that this is going to be directly proportional to the normal, and we're going to have a coefficient of a static friction given as that. So therefore, for us to find the coefficient of a static friction, we're going to have it as our subject here, which is equivalent to static force maximum divided by the normal given as that one. And we had been told that this specific normal basically is equivalent to the weight of this specific object, which is 50 newtons. So therefore, we are going to have the coefficient of a static friction equivalent to the force applied maximum, which is 40 newtons divided by 50 newtons given as such. And this is going to be equivalent to 0.8, the ratio for 0.8 for the coefficient of a static friction given as that. So for the third case, we are required to evaluate when the block moves at a constant velocity if the force applied is reduced to 32 newtons. So in this case, the block moves at constant velocity if the force applied reduces to 32 newtons. So we had indicated in our previous video that basically if we try to compare this aspect of a static friction maximum and of course this other, of course, a sliding friction, which we refer to as kinetic friction, we are going to see that this static friction maximum is going to be greater than the friction which is going to be, or the force which is required to move the object while it's in motion is greater than the force which is going to be required to start the motion of this object. And therefore, we are going to find this one that we can do an evaluation of this one in order to find the coefficient of kinetic friction, which is given in terms of a UK. So we had decided that the relationship between static friction, kinetic, this is sliding friction, is equivalent to mu K, and of course we are going to have our normal. So for us to find the kinetic, the coefficient of kinetic friction is equivalent to this specific ratio we're going to have for Fk divided by N, and this is equivalent to 32 newtons all over normal, which is 50. And this is going to be giving us 0.64, a ratio of that one. So in comparison with the previous one, we can see there's a slight variation in the coefficient of friction given as that one. And of course, we're going to see that this is going to be the case, especially for this specific condition which we have just described for the case above. So kindly check our description boxes for various links of other similar videos. Engage us in the comment section and also ring that notification bell for various updates in uploads in math and sciences. So that is it for now, guys. Bye. God bless you. Catch us in our next video.